question 7. Question 7 of exercise 8.1. Any issues with question 11A? 11A, 13, 11A. How about 13? 23, 26. Okay. It's not as bad as I imagined it. I was thinking that I might need to go through everything. Okay, after I finish going through this, then I'll run through a little bit of things in your binomial homework, okay? Okay, let's look at 11A first. Okay, can you minimize your discussion already? Okay, so now this question gave you the equation of a circle, wants you to find the horizontal tangents. Okay, so we can imagine a circle itself. Horizontal tangents, there can only be two. Okay, one of which is all the way at the bottom and all the way on the other one is all the way at the top. Okay, these tangents, okay, being tangents, they must satisfy the property of tangent perpendicular to radius. Okay, so from the center, if I want to draw the radius down, it must be perpendicular like this. Okay, and since we're looking at horizontal tangents itself, okay, they must be so-called directly below and above the center. So if I know the coordinates of the center, okay, then with the x coordinate and the y coordinate, okay, I will be able to know, okay, what is the equation, as well as, sorry, I also need the radius length also. Then I will be able to know what is the equation of the horizontal tangents. Horizontal tangents being horizontal lines must have the equation y equals to something. Okay, so I must know what are the y values. Okay, if I want to draw in my x and y axis. Okay, what's the y value here and what's the y value here? We reference from the center coordinates. Okay, A and B. Okay, so that's a diagram that we use to guide ourselves. Okay, so using your standard form, expand. Okay, compare with the given equation, which is in general form. Okay, given the equation in general form to be as such, we move the 12 to the left hand side. By comparison, we find that A is -3, B is 2, R square will be equals to 25. So R is equals to 5. Okay, so we have the coordinates of the center now, which is -3 and 2. Okay, so that means that with the radius being 5, it will be 5 units above 2. That means that this will have to be 7. Okay, and then 5 units below your 2, so minus away 5, so therefore that will be -3. My diagram is meant to drawn as a facilitation, it's not meant to be accurate. So therefore my equations of the horizontal tangents will be y equals to 7 and y equals to -3. Okay? So that's how we solve question 11A. Okay, let's look at question 23. Okay, question 23, they provided you with a diagram, and then they want you to find the equation of the line BC, C being the center, B being the line of the tangent. By our property of tangent perpendicular to radius, we know that there must be perpendicularity over here. Okay, since I know the equation of the tangent already, I can manipulate that to figure out the gradient of the tangent. So what I need to do is to change it into y equals to mx plus c format. So gradient of tangent is 4 over 3. Therefore, the gradient of BC will be negative 3 over 4. Okay, since I know that B, I know the coordinates of B already, which is along the tangent. It is also found along the line BC. Okay, so therefore equation of BC should be y minus away z. Oh, sorry, don't do this right. Y equals mx plus c. Y equals to negative 3 over 4x plus c. 0 equals to this, C equals to 6. Therefore, y equals to negative 3 over 4x plus 6. Okay, so that's how we get the equation of BC. Okay, I think the challenge lies in part 2. Okay, part 2 wants us to find the coordinates of C. Okay, are we paying attention? Trying and carry your conversation. Okay, I hear a lot of chattering. I know that maybe you want to discuss and all that, okay, but it is rather disruptive. Okay, part 2, we want to find the coordinates of C, right? But the problem is that we don't have much information, okay? We don't know what is the radius, okay? We only know the equation of BC, and that's all, okay? Pretty much it, alright? So what we can do is that with the equation of BC, I will know that if, let's say, the coordinate of C were to be x, the y coordinate must follow this formula over here. Okay? So that means that if I let C, alright, have the coordinates of, let's say, x coordinate be A, the y coordinates must be negative 3 over 4A plus 6. Okay? So this is something that we can actually deduce based on the equation of BC. Okay, but so what? This is definitely not the answer that we want because I must know what is the value of A. Okay, the only other way around this is to make use of the coordinates of A, okay, which we have not yet used. Okay, we know that A is found on the circle, B is found on the circle. If I were to draw a line from A to C, it should be of the same length as the line from B to C. Okay, because they are all radius. Okay, so we know that AC equals to BC. This is the only information that I can gather out of this question. Okay, so therefore I must go and find the length of AC and also find the length of BC. Okay, so using my length formula, Okay, I will be able to get this for AC. Let's avoid expanding it entirely. Okay, let's keep it compact first. Go and find out what is BC, so that later on maybe you will have something that's algebraically easier and neater. Okay, so if AC equals to BC, that naturally means that AC square must be equals to BC square, so I can get rid of the square root. Okay. Then at this point, you realize that actually you have no other choice but to expand. Okay, so expand on. Okay, for this one, the expansion need to be careful. Okay, this is the A minus this is the B, then bracket square. Okay, so that means A square minus 2AB. B is just 1, the minus is taken account into the formula already. Then plus 1 square. Okay. Then same goes to the other one. AB plus 6 square. Okay, so simplify. We can remove the A squares. That means we are balancing the equation by minusing, so-called subtracting A square on both sides of the equation. I can also remove this since they are equal on both sides. Okay, so essentially I'm looking at having negative 2A plus 1 plus 3 over 2A plus 1 on the left hand side minus away 3 over 2 minus 9A plus 36. Okay? Place all the A's together. And all the numbers onto one side. And we should have 49 over 2A equals to 98. 6, 7, 8, 9. So A is equals to 4. Then your Y coordinate will actually be 3. Therefore, center is at 4, 3. Okay. Okay, once the center has been found, I believe the radius shouldn't be much of a problem, since it's just placing A into this, either one of this, and then you can find. So radius is actually 5 units. Okay, then you can find the equation of the circle already. Alright? Any questions? Right? Circles question, you see that usually, I mean for now, starting, your question parts tend to be like part 1, part 2, part 3. But notice that you see, in recent years in your 10-year series, they tend to give one shot, one question, few lines only, and then like 10 marks. You have to do it. Okay? Yeah, so you need to know how to, come out with the plan in terms of answering. Okay? Otherwise, you will find that it's a challenge to solve a 10 mark, 12 mark question, okay, with very little information. Alright, next we look at question 26. Okay. Okay, just want to know for question 26, is the concern in part I? No. Then the concern is from part 2 onwards, is it? Part 4. Okay, can. Question 26. Okay, that means that, right, at this juncture for question 26, you will already know the radius of your circle 1 and your radius of your circle 2. So, I'll just write things here. Okay, circle C1 will have the radius of 3 units. Right? And then for circle C2, the radius is found to be square root 20 units. Question wants us to find out whether the circles intersect each other or not. Okay, so how does intersection of two circles look like? It just simply looks like overlapping of Venn diagrams. Okay, so that's the idea of intersection we're looking at. Okay, so why do I talk about radius? Because if I know the center of C1 and the center of C2, right? Okay, let's say if they do not intersect, okay, if they do not intersect, maybe let's join two separate circles. Okay. If they do not intersect, means they are far apart, no? Okay. What it will look like is that the distance from the center C1 to the center C2, this distance itself will naturally have to be more than the sum of the two radius. Correct? Okay, so this length itself will be more than the sum of the two radii. Okay, if they overlap, what does this mean? It means that this distance will have to be lesser than the sum. Okay, if they meet just nice, okay, that means looking like that, right? That means that, okay, this distance itself, the total distance, must be exactly be 3 plus square root 20. Okay? Okay? So that's what we need to have as an idea first. So in order to check whether are they overlapping or not, what we will do is to go and find out what is the distance between C1 and C2. Okay, so we have the coordinates of the two centers. center C1 has the coordinates of 5, -2. And then for the center of C2, that has a coordinate of -2, 3. Here we get for square root 74. Square root 74 is about 8.60. Okay, whereas 3 plus square root 20 gives us about 7.4721. Okay, so that means square root 74 is more than 3 plus square root 20, and therefore they clearly will not intersect. So we explain that since the distance between the centers of the circles is greater than the sum of the radii, okay, then therefore C1 and C2 do not intersect. Questions? If not, could you please pass your homework down to the front? Except don't have the graph paper for you to draw. Use the drawing. Okay, pass your homework down to the front, please. Okay, in the meantime, look at your chapter 6 homework, your binomial theorem homework. Okay, there are certain things I want to point out. Why only got 2? Let me talk about your friends at the back. Okay. Wait. Come on, pass your paper down to the front, please. Oh, just like the recorder. Oh, you asking if you want to stop now? Okay, stop. Sorry, stop. Thank you.